Question here that's given us a graph. Okay, so we have something to look at, and it wants us to follow some of the function notation and find some values. So it's really interpreting this graph on the left-hand side and figuring out what the notation is asking us. So first of all, we have two functions, one called f at x, which I'll underline in green, and I should change the color for g at x. G at x will underline in red. Okay. Question number one actually just deals with f. So we're only looking at the function f, which is like our quadratic that's facing downward. G at x looks more like a linear function to us. This is asking, when x is 3, what is y equal to? Well, we can take a look at this. When x is 3, it looks like y is probably 2, so the coordinate of 3 and 2. So in this case, we can say f at 3 is 2. Okay. What about 5? When f is 5, it looks like we have 5 and negative 4. So we can say that is equal to negative 4. What about negative 4? We jump back, negative 4, I think it's connecting there. Negative 4 and negative 5. That means f at negative 4 equals, oh, I've lost my cursor again. There it is, negative 5. And then finally, f at 2, this value here, 2 and 4, that equals the value of 4. I'm sure they'd want you to write it out a little nicer. I just kind of saved some space there. The second one asks, find values of x such that g at x, so a completely different function we're looking at, values of x are underlined in red, is equal to 1 and negative 4. So this is when the y coordinates are 1 and 4. What are the x coordinates? So look at g, and when y is 1, okay, I can kind of draw a horizontal line here, and it, whoops, that's f. Here's g, looks like it's negative 1, so that coordinate being negative 1 and 1. So here you would actually say g at negative 1 is equal to 1. And negative 4, same concept, we go across. Looks like it connects right at that same coordinate, so we'd say y, whoops, no, g at 5 is equal to negative 4, okay? The third question, same concept, but this one's a quadratic, so a little trickier. We're going to end up with multiple values most likely here. We're looking for the y value of 2. So we look at 2, it crosses here at 3 and 2, but it also crosses at, that look like negative 2? Yeah, negative 2 and 2. Negative 2 and 2. So in this case, we actually have two answers. We're going to say f at negative 2 equals 2, and f at 3 is equal to 2 in this equation. Same for 0. We take a look at 0. Oh, these are not nice values. We'll just assume they're half values here, and we'll say f at negative 3.5, we'll write it as a mixed number here, is 0, and f at, actually that would have been 2, negative 2.5, and this one looks like it may be, 3.5. You can get a little more specific here, but that's the general idea, is that there's two answers. That's what we're trying to look at. Next one is a neat one. It's asking for when they connect. When is f at x equal to g at x? Well, there's two values here. Right here and right here, they both cross each other. So the coordinates for that are negative 2 and 2, negative 2 and 2. So I'll write it underneath. Negative 2 and 2 is the answer. And the other one is at 5 and negative 4. 5 and negative 4. So there's two answers to that. And then determine the equation of g at x. Well, this is a linear equation. We can try to find the slope to it. Let's see, it goes down 2, 3, and over 1, 2, 3, 4. So down 3 is negative 3. I'll fit it over here. So if we're doing a rise over run, we say negative 3 over 4. And then we'll say y is equal to, what is the y-intercept? Not a nice y-intercept. Maybe it's positive 1/4. We can get a little more specific and take two of the coordinates and solve it, but we did a little estimate graphically to just determine that one there.